poor little thing. What does that symbol here mean? This is not supposed to be your state of mind. I know, it's a bad joke. I don't care.
Funny.
Okay. What does that symbol mean?
G and F.
Yeah, G goes into F.
Yeah.
It's the composition. You plug G into F, right? None of those says to multiply two functions together. None of them. You guys with me?
Yeah.
That's where that problem came from when it said to plug F into itself. Bam. Yes, maybe. Is that all right? You guys can ask follow-up questions too. If my initial explanation sucks, I'll try again. That's fine. Okay, I like it. Yes?
For number 4, there wasn't any equation, right?
I know, I love number 4 because it's so wonderfully evil.
I was like, what in the world is this?
You don't have to suddenly be an agricultural wizard. Do you think crops will do better if you put a little fertilizer down?
Yeah.
And the yield is just how much you get from them? Yes?
Yeah.
Okay, I like it. So does that mean if I just put like crazy amounts, I'm gonna yield a ton of stuff?
No.
Think about what I just said. This axis is the amount of fertilizer you dump, and this axis is the amount of yield you get. So a lot of people are just doing this, which is neat. Right? So the answer is, dump more shit on it. Yay! And then I make a lot of corn. No.
No. We're gonna have
Eventually you're gonna
some
freaking
already.
cover the plants. I mean, I don't wanna go to that farm that has manure up to the point where it's covering the corn plants. No, that's a bad place to go. You guys understand? I understand that problem is weird, but it's actually kind of nice. It's a little open to interpretation, but there are certain things that I need to see happen in your graph to make physical sense. Is that better, or? Okay, I'm sorry, there's somebody over here, yes?
I was just, the way I had it is like I had it still like gradually go up because the more plants you get, the more fertilizer you have to use, right?
Oh, okay, I like it. Yeah, you're right, you're thinking of it backwards, but again, imagine somebody who's just piling the fertilizer up. At some point, you're gonna smother the plant. It's not going to make anything for you. So that should show up on your graph. Don't have somebody that's just going up and put an arrow, because now somebody's like, I can get infinite yield with infinite shit. No, so it's not a good goal, right? You don't like it, maybe? Okay. By the way, I just want to warn everybody. Let's see if anybody comes and grabs it. That stuff. You have to show work unless they specifically say you can use a calculator, right? You can check your work. Sorry?
You know fertilizer.
Oh, I mean, all right, come on. All right, guys.
When you're back.
Guys, this is where I love it, where I get people that are like, all right, 8 times 9, let me write 9 8 times for this jackass at once. Work. No. That problem, obviously, you're going to capture the idea in a graph. You don't even have to say any words if you don't want to. That's fine. Work where it makes sense. You gotta show work where it makes sense. I don't like answers coming magically out of nowhere. Right? So if you tell me the answer to that with no work anywhere, that's bad. Right? Don't say, well, my calculator started. I don't care. Right? It didn't say to use your calculator. You guys kind of a little bit. Did it make anybody else happy now?
You have another question.
Yes.
So I wrote the answer for one of the questions. I'm trying to remember really which one it is. I didn't show where because I don't know why answer.
Oh, neat. All right. Well.
So,
let's see. Yeah.
could we go over it?
Oh, which one?
Hold on, I have my book with me.
Anybody else has a question? Feel free while she's looking stuff up. Yes.
I had a question on 17C. I just don't know how, for the 17s, I've been graphing them and then seeing what they're not.
Oh, okay. All right.
Yeah, and that
See,
one
this
doesn't
is
graph.
This is a great question. It's how the hell do I show this is even and odd by hand, Jeff? That's a beautiful question. Okay. And again, if you don't have the book yet, that sucks. But if you do have the book, you can go back and find where they discuss ideas and kind of read back up on it. But So does everybody see the problem? Determine whether these are even, odd, or neither. Does it have a little calculator symbol next to it? No. Oh well, shit. You gotta do it by hand. So, given an f of x, how do I show, oh shit. What's wrong with you? Okay. How do I show it's even or odd? Does anyone remember the test? Yes.
It's f of x equals f of negative x.
Okay, so if I plug a negative x in and I get the same result, okay, let's think about that. So if I plug an x in and I get that, and if I plug the opposite of that, the negative of that input, and I get the same output, can you guys imagine the most simple function that, well, there's a really simple function that does that's really boring, but something non-linear that does that kind of thing? Yeah, I heard it, I think. Parabola, which has what kind of function? What's the function for a parabola, the basic function? X squared. I love it, right? What type of power does it have compared to x cubed? X squared has an even. That's even symmetry.
Yeah.
That's how you remember this. So an even symmetry is going to have a property similar to a parabola, namely, Jeff can't draw it. No, I mean, namely, you find the mirror image across the y-axis. What does that mean more technically? When I plug in one input and I plug in the negative of that input, I get the same output. That is even symmetry, and it's so beautiful because it's related to x to an even power, right? I'm so excited. All right. Maybe. So this is what, you don't want to straight out memorize something. You want to tie it to something that's easy, that you already kind of know. Don't memorize this for even. Say x squared even, what does an x squared look like? Oh yeah, that means this has the same output for the two inputs. Does that make any sense? The more you feel like you have to memorize shit, the less far in math you're going to be able to go, because at some point you get to the, we're all full, right? Okay. So this would mean even symmetry. So let's see this in action real quick. We just said that's even, right? How do I test it? What do I get when I throw a negative x in? What do I get?
X.
Holy shit, I get the original function. There you go, check. Even. That's how you actually apply the idea. I like it. So what do you think odd would be? What does x cubed look like? Can somebody draw it in the air? X cubed? Dude, all right, that was a neat. I got your idea. One of my colleagues calls this the giraffe graph. And I always have to joke him because it's like the front leg got cut off, Corey. The giraffe is just going to, oh shit, going to fall over. But it's fine. Poor little giraffe. I just call it cubish. It's got to be one of our basic functions we know. So what happens when what's 2 cubed? 8. Holy shit. What's negative 2 cubed? Negative 8. So this thing has some really weird symmetry. It's got symmetry through the origin. If I draw a line from here through the origin, I will end up here. Or, if I rotate this thing around the origin, won't this swing there? All right, now, what does that mean mathematically? Well, you can pretty much tell what it means. If I plug a negative x in, do I get the same output? When I put 2, I got 8. When I put negative 2, I get negative 8. So how does that relate to the original? It's opposite. I like it. So that is the test for finding odd symmetry. So the beautiful thing is, what's the test for even or odd? Plug a freaking negative x in, and then see what happens, right? So what about this? Yummy. How do I test this for symmetry? What do I do? Plug in negative x. What's cosine of negative x? Oh boy. Well, this is one of your identities you have to know. And think, all right, guys.
Cosine x.
Yes. Why am I going up there? Think about this. What does a cosine look like? What's a cosine look like? Where's it start at 0? 1, and then it's octopus, right?
Yeah.
Octopus. So this doesn't mean you get the answer just from remembering the graph. But since you know cosine does this, if I plug in f of x and I plug in f of negative x, don't I get the same thing? So that's an identity. You know that this is cosine x by identity. So therefore, what kind of symmetry does it have? Even. Kick ass. Is that better for that section? Everybody that got that back and I said, show work. I should have worn my shirt that says, show work. I'll do that later. Okay. Yes?
So, can we go back and just do the one, or do we have to do the whole thing?
You only have to redo the ones that you got wrong. Yeah, even if I say redo, just redo the ones you got wrong. Yeah, you don't have to redo the ones you got right. That's fine. So the distinction for me is if I say correct, you currently have half credit. If you correct the mistakes and get enough right, you can go back up to full credit. You guys with me? If I say redo, you currently have no credit. But you can redo the ones you got wrong and get back up to full credit. Holy shit. It's crazy. All right.
For 17D, though, the answer was neither.
Definitely.
So what's the difference between that and then the example you just did for cosine?
Because what happens if I have a combination of functions? What do you think x cubed plus x to the 5th? What kind of symmetry do you just think that has? Odd, because it's the sum of two odd functions.
Yeah.
Right? Kind of makes sense. Now to prove it, you would do the negative x thing. What happens to 1 when I make x negative x? Does it give a shit?
No.
Nope, it doesn't change at all. So the only way this can have some kind of symmetry is if sine also stays the same. Does that make sense? What is the opposite of f of x? What is the negative f of x? What would it be? All right, let me put it up here. If f of x equals 1 plus sine x, can you guys see that? Probably not. Okay. If f of x is 1 plus sine x, what is negative f of x? Yeah, negative 1 minus sine x. Yes? Both of them have to change sign in order to say the whole function changed sign.
Oh, okay.
One doesn't change sign, but what does sine do? S-I-N. Well, I'll let you guys do it. Okay.
That makes sense.
So when you have a combination of functions, you have to be a little more careful.
Okay.
Yeah. So what about x squared plus x to the 7th? What kind of symmetry does that have?
Would it be neither? Because it's
Neither.
a combination of both? Okay.
Because x squared wouldn't change sign, but x to the 7th would.
Got it.
So
That
does the
makes
whole
sense.
function stay the same? No. Does the whole function become negative? No.
Got it.
I like it. So it doesn't have to be one or the other. All I have to do to a parabola to officially make it lose symmetry is move it a little bit, right?
Yeah.
Move it. Right.
Okay.
Do you guys remember what we do when we find parabolas? We talk about the vertex, we talk about intercepts and all that shit, but we also talk about the what? What goes right down the middle? Axis of evil. I mean, axis of symmetry. That's right. Sorry, took us back to Bush days. Probably before some of you guys were born. Shut up. So, I can extend the idea of symmetry. Kind of makes sense. It shouldn't lose all of its symmetry just because I move it. So we kind of say, okay, for this specific one, that is the mirror, right? But to officially be even or odd, your mirror has to either be the y-axis or the origin. Maybe, are you guys all right? Okay. Anything else from that first assignment?
25D.
This one here?
Yeah.
Oh yeah. Didn't we do a problem like that on our first little worksheet? The warm-ups? It was a bonus problem, but we still did it. No, you guys are like, dude, if it wasn't this morning, I don't know what the hell. Okay. So if I had to do tangent of inverse cosine of 2/7. Does anyone remember how to do that? There's actually other ways to do it, but to me, the way I did it before is the easiest way. No. Not a bad idea, but it won't really do anything for us here. No sense. Yes? Yes, okay. This inside, so again, guys, what must the inside of a trig function be physically? What do you take a trig function of? An angle. That's the basic definition of trig functions, right?
Yeah.
So that inside is an angle. Theta. Which means, catching up to what somebody just said, this says the cosine of theta equals 2/7. Can't you draw a triangle for that? No? Can't you draw a triangle because you know the ratio cosine represents?
Yeah.
Okay. This is where some of you guys that it's been a while since trig, or you really didn't do that great with trig, it's where you go, oh shit, there's going to be trig everywhere. Yes, there was going to be trig everywhere, right? So you have time still right now to review, right? Did anybody realize on Canvas I put the trig laws that I need you to know? So if you haven't gone on there yet, they're up there. And I think I put something else about trig. I can't remember now. Oh. What does this triangle look like? Looks like that, Jeff. No, I mean, where does... I can label a couple sides now, right? Do we know what this is? 2. Do we know what this is?
No.
No, not yet. But do we know what this is? Freaking 7. I love it. Because cosine is x over the hypotenuse, right? 2, 7. They want me to know tangent. I can now figure out what I need for tangent, correct? You guys okay with that? So then, what's this side then? 3 root 5. Okay, so it's 49 minus 4, 45. Square root of 45. Take the 9, 3. I got you. Okay. So this is 3 root 5. Just want to make sure everybody sees where that came from. Good old Pythagorean theorem, and then simplify. And now what's the tangent? Three rad 5 over 2, right? Because it's y over x. Kick ass. Now, you could check that in your calculator. No problem. But some of you guys are just doing it in your calculator. And then your calculator passes the class. It goes on to have a nice life. Finds another calculator, has some babies. And you guys take calculus again. Yeah, so I don't care if you don't think that's a good joke. I love that joke, right? But what I'm trying to tell you is do the work. Unless I specifically say you can use a calculator to do something. Anything else from chapter 1 while we're talking about it? Anything?
No, but thank you.
Huh?
Thank you for explaining.
Oh, yeah.
Okay.
That's like my job.
Because, yeah, we did do that.
And again, just to remind you guys, anytime I explain something and it still doesn't make sense, don't hesitate to go, I didn't quite understand that, right? That's kind of my entire job. Yes?
Can you do 27B?
27. Wait, did I assign 27?
It was
Oh,
22,
you did.
26.
Yeah.
Oh, I thought it was 1 through 28. Oh, my
No, that's all right. No. Yeah, 27 I could have assigned to you, but we're going to talk about that. We're going to kind of review that stuff later. Because that's one I think that most of us probably will have forgotten because it's normally really quick in pre-calc. And some of you guys might not have talked about it at all in pre-calc. It depends on which teacher you had. So that's why I didn't assign that one. We'll review it, redo it when we get to that section in the book. Yes?
Well, when's the test again? The test?
Oh, well, how do you know where the tests are? Yeah. So let's do this. I will announce when our first, because I don't think I've announced this yet, have I? The first quiz? No. So I could have done this one of two ways, but I've decided to have a quiz on chapter 1 Wednesday. Because I am evil. Okay. So definitely by Wednesday you should be ready to turn that chapter 1 in if you haven't done so already. Okay, I like it. And quizzes are normally not crazy hard. They just go over the basics, right? The tests aren't like crazy hard either, but they're harder. I like it. I like it. And I think we'll have a quiz on chapter 2 next week, so we'll talk about that on Wednesday, when that's going to be. All right. Anything else, guys, before we get into section 2.4? Yes.
So we want to have all we want to have all the homework for the chapter.
Oh, all right. So I try to assign a quiz on the day when you should be ready to turn homework in. Homework is not late until it's turned in after the test. You guys good? But if I tell you a quiz is coming up, you definitely want to do enough to be ready for that quiz. But you don't have to turn it in necessarily if you're not quite done. I like it. Okay. I try to strike a balance between making you do the homework so you get the practice, but giving you some allowance for shit happening in your life and you do it where you can. I try to strike a balance. Okay. So, last time we did that worksheet about limits. Let's see if I still have it with me. Here it is. I don't even have the answers. I can't remember. Yeah. This bad boy. Remember this guy? Oh, yeah, that was fun. Okay. All right. That wasn't too bad, right? I mean, computationally, conceptually, I'm hoping it's not too freaky. You have to remember how to factor, all that kind of stuff. I like it. By the way, I'm going to email you guys. We're having some factoring workshops just in case you want a refresher this week. So I'll email you guys the what do you call it? The times and the days for that. I can't remember off the top of my head. But just in case you want to attend that, get some. And normally I give extra credit for going to workshops. Not like a ton. Don't get too excited, but a little bit. Okay. So what we're going to do today, if there's no questions from chapter 2. Are there? Yes? No? You're good? Okay. Is we're going to do a deep dive into a limit. We're going to do like our first proof, 7. Right? So let me start with this. Let me just see if you guys can get in the direction of what we need to do. What should be true if a function has a limit? So let me draw this. Let me put this up here. So let's say I have a function and I want it to have a limit L at A. All right, let me just leave that up there. So the limit as x approaches A, for both sides of course, because there's no plus or minus, of the function, I want it to be this number, L. So L is not infinite, it's finite. What has to be true about the function? Do you care where the function is over here? Does it matter where shit? No. Could it be at infinity over here? Well, let's say -5. Could it be at infinity? Of course it can. Whoa! You don't care what it's doing over there. Where's the only real place you care about what the function's doing in order to match that requirement? At A, and close to A, correct? So in fact, let's even say that it's undefined at A. Right? So this is kind of interesting. I think you can sell me this, but then it's going to be that jump to the specific way to write this mathematically that's going to freak us out. What's got to be true? I don't care. It could be an infinity over there. Hell, it could be an infinity right here, right? It could do anything. Whoa! No, it can't become not a function, Jeff. Oh, well, too bad. So it can't like go back on itself. Oh, Jeff, why did you do that? All right. There you go. All this is not canon. This is not canon down here. Okay. But what, of course, has to happen, the closer I get to A, my outputs have to get closer to L. So let's write that down. So it only makes sense. The closer I get to A, my outputs have to get close to L from both sides. So it could be doing all kinds of weird shit, but eventually it's got to be going. So as X approaches A, f of X approaches L. Okay, that much we know already. Now let's be more specific. The closer X gets to A, the closer f of X must get to L. All right, so this is the general way we discuss limits. This is one step closer, one step closer to the formal definition. What does close mean? Have you ever had somebody who stood too close to you to talk to you? Right? If anybody watched Seinfeld, that they have names for this kind of. So, but each of us have a different kind of boundary. Right? You with me at all? Some people are cool with like being right up next to somebody, but some of us are like, no, my boundary starts here, unless I know you, and then it's here. Right? You guys kind of with me? So, what does close mean in math? What does close mean in math? We don't know, Jeff. All right. So here's what this means. If somebody tells me how close they want me to get to the limit, don't worry, I have a computer that can draw some better pictures than me in a minute, okay? Well, almost anything could draw a better picture than me. If somebody tells me how close they want me to be, and what we always use, there's two letters we use to represent what we normally consider to be very small numbers. And those are epsilon and delta. Oh, shit. So this is going to be epsilon. It's like an E, but it's a C with a line coming out. That's epsilon. And then, so here's the idea. If somebody said, okay, if that's the limit, then I want you to get within 0.1 of that. And then we go, okay, well, if I get within delta, become a thing, there we go. If you want me to get within epsilon of the supposed limit, I'm going to let my inputs get within delta of the input. Okay, this is hard. I really want you guys with me. So somebody can come up to me and just say, okay, I want you to be within 0.1. And I'm like, all right, well, to be within 0.1, I'm just going to let my inputs go from here to here, because then the outputs are always in there. And they're like, okay, I want you to be within 0.01. And I'm like, no problem. I'll just make this little thing like that. And then I'm always in that little area. So let me show you the picture, because this is really weird to imagine. Oh, let me back this up a little bit. Hold on. Yeah. There we go. Okay. Which one are you? You're A, I think. Yes. All right, so this is a pretty cool little thing here. So somebody has come along and said, I want it. All right, let's take a look at this function first off. Here's the function, 4 minus 3x squared. Now, obviously, what is the limit as x approaches 1? Why am I over here? As x approaches 1, what is the outputs? What do the outputs approach? 1, okay. 1, 1. if that's true, there must be a way for any number somebody gives. So somebody came along and said, I want you to be within 1 of 1. So from up to 2 or down to 0. I want the output to be in there. Can you figure out a neighborhood? Can you figure out a distance away from 1 so that I'm always in here? Now, the way I've got it set up currently from 0.5 to 1.5, do my output stay in here? No, what's the output here? Shit! And what's the output here? Off the screen, right? So how do I make it so that I get my outputs to be within what they set up for me? So can you guys imagine, currently I've gone half a step up, half a step down. Do my outputs get as close to 1 as they want me to? No, because I'm not in this box. So of course, what am I going to have to do here? I'm going to have to make it narrower, right? Okay. So as I make that narrower, so delta is the amount up and down from 1. For you guys, up and down. Okay. So if I make delta get smaller, watch what's happening. See my output? And my output down here is going to eventually come back on the screen. Now something interesting happens. Did the top output get into the box now? You guys see that? The top output got in the box? Is the bottom one in the box also? Shit! So then I got to make it a little bit smaller. Hey! I don't know if you guys are with me. Don't worry. We're going to go further. The power of this is, what could this be? It doesn't have to be 1. It could be anything. If for any distance from the limit, if I'm able to always find distances from the input that I'm in there, then that limit is true. I have to always be able to find that. I like it. So, what if somebody what if he said, all right, that's good shit, but I'm going to make epsilon 0.3. Oh, shit. So then what do? I make delta smaller. Oh, the top one, there we go. There we go. So I had to make delta smaller. Can I do that forever? Yeah. No matter how small they make epsilon? Of course I can, right? Now, just to make sure you really understand. If I had incorrectly thought the output was, if I thought the output of 1, that the limit was 2, I'm screwed. I can't stay around 2, can I? It has to be 1. That's the only number this would forever work for. So that's why 1 is the limit. Okay, maybe? Do you guys get a little bit of a feel for this? I'm sure right now, somebody out there is like, what does this mean my homework is going to look like, Jeff? Dear God. Or if you haven't thought about it, now you are, right? What the hell is my homework going to look like? Mr. Can't use freaking calculator shit to do it. All right, so now we got it. This is concept. Now we're going to translate it into by hand work. I like it. Okay. Now what's funny is, do you see how wide this is and how narrow this has to be? Because this guy's slope is kind of huge here. So if I were to make this, let's say, oh, Jeff, I don't know, let's see. So now it's up here. Now it could be, why can I know I changed the limit, but oh well. Can't my box be wider now? Because the slope between them is much more gentle, right? Now how much is that going to affect your work? Not at all. But I want you to understand the way the function moves and how close they want me to get both affect how wide this can be. So you can imagine some insane cosine function where this is going to have to be stupid tiny to be able to handle all that shit. So the nicer it is, the less tiny this has to be. Okay, maybe. And then one more thing I want to make. Anytime somebody changes epsilon, my delta needs to automatically change. Right? So let me talk about that for a second. Let's say that, how do I want to say this? Let's say that it takes you half as long to get ready to leave as somebody else. You understand? It takes you half as long to get ready to leave than your friend. And your friend says, I'm going to start getting ready, so I'm going to be ready in 20 minutes. And then we got to go. When do you need to start getting ready? At 10 minutes. 10 minutes from them. You with me? What if they said 30 minutes? 15. Okay, so you have figured out a rule so that no matter what the other guy says, you know what to do for yourself, right? They give you their time frame and you can change it so that you'll match that. Okay, maybe it's not the best example in the world, but too bad. So, we're going to see something very similar happening here. Our delta is going to be some multiple of epsilon most of the time. Right? So as they change epsilon, our delta automatically changes to make sure that I'm always in there. Okay, maybe. So, let's formalize this a bit, which is a much hated phrase in mathematics for math students. So, oh shit, let's switch this. Okay. I am zoomed in. Okay, focus. Back down. Okay. All right, so to formalize this, given f of x, right, we're given some function. For the limit as x goes to a of f of x to be L, for that to be true, right, this is a little clunky, Jeff, but it's all right. For that to be true, if we are given an epsilon greater than 0, okay, since epsilon's a distance away, it makes sense it's got to be positive. So if we're given an epsilon greater than 0, so they give me some target distance to be within, we must be able to find a delta so that if f of x, oh shit, this is going to be freaky. All right, let me stop for a second. What do the absolute value symbols really represent? Very one-word answer. Anybody?
Positivity.
Why is it always positive? I want the fundamental idea.
Far away from 0 it is.
I like it. I'll make that one word, distance.
Yeah.
It's based on distance. I like it, which is why it's got to be, you're not going to say somebody's negative 4 feet away from you, right? Even if they're behind you, they're 4 feet away. If they were negative 4, they're in you or something. Quaid. No. Quaid. No? Okay. Nobody's watched Total Recall? That's fine. So if we're given a distance away from 0, we must be able to find delta so that if the distance between the output and the limit is less than epsilon, so that's this, right? They have set up this. I love you, Jeff. All right. Strike this for a second. I'm sorry. I'm getting ahead of myself. So that if my input is less than delta, then my output is within epsilon. That's better, Jeff. All right. I was so focused on how to explain this, I brought it in too early. So if we are within delta of that input that has the supposed limit, then our outputs are within epsilon. Okay, that's better. Okay, this still doesn't make you, this makes you feel even worse about what your homework is going to look like, I'm almost certain, right? But let me stop for a minute. I apologize for getting that backwards. But does it make, it follows with what we were just doing. Given an epsilon, I need to find a delta so that anytime I am delta away, then my outputs are epsilon away. Trying to make sure we're in that little region they gave us. That is exactly what we were just doing on that Desmos activity. Okay, maybe. Now, let's do an actual example. Yes?
What value is A?
Oh, A is just, if you claim that the limit as x goes to 1 of some function is 3. A is 1, L is 3. A is the value that you think you know the limit of the function at. Yes?
And then L is the limit.
L is that supposed limit. Yes. So A is the input that we think the function approaches L from both sides of that input. Okay, I like it. All right, so this is going to be, all right. You're all like, just do the problem, Jeff. I need you to understand. This proof sets up proofs later in this class. Some of my colleagues skipped this section, and right now you're all like, oh, why didn't I take them? All right. But the reason I don't, and some other colleagues don't also, is because this idea comes up later in Calc 1, Calc 2, Calc 3, other maths, right? So right now I want to lay the groundwork. So this is going to be freaky, then it's going to click for some of you guys, and then it's going to be too easy. All right, and you're all like, let's see. Okay. I love it. You're all like, I don't, too easy. I don't know about that, Jeff. All right, let's find out. So let's work with something. So we have f of x equal to x squared minus 1 over x minus 1. We claim the limit as x goes to 1 of f of x is 2. Okay, some of you guys might be able to see that that's probably going to be true, but now we're going to prove it for real. All right, so we need, here's what we want to do. So here's the proof. We need to find delta greater than 0 such that for epsilon greater than 0, Jeff, if x minus, all right, let me see if you guys can fill this in. All right, let's see if you guys can fill this in. X minus what?
-2.
And what's a in there? Good. And if that's less than delta, right? Delta and epsilon are basically the same idea. It's some really small distance. Delta is what we call the distance on the x-axis. Epsilon is what we call on the y-axis. If this is true, then what? All right, so let's write it like that at first. F of x minus L. Now fill it in. X squared minus 1 over x minus 1 minus 2. I like it, right? Here's the limit. Limit's 2. That's L. Is less than epsilon. So again, it's so easy as a math student to get lost in the details of this. But remember, behind this is all, it's just the idea of if I get such and so close to here, and that really is the limit, I should be able to find something that stays in there. Yes, maybe? Yes?
Epsilon is y, right? Epsilon is for y, right?
Yeah, epsilon is for the outputs, and delta is for the inputs. They represent the same kind of idea, the distance away from something, but they don't have to be equal to each other. All right, so what the hell is this going to look like? So, how much time? Oh, good, we got lots of time. You guys are like, damn it. All right. The first step of this proof feels like we're cheating, but this is a type of proof called construction. I'm going to construct what I need. What do we need to find first? What is actually the whole point of this? I have to be able to find what? What do we have to do? Yeah, we're given epsilon greater than 0. We're given that. We have to find delta. That's our whole purpose, is to find delta. So watch this. We're going to start backwards. We're going to say, okay, let's say that this is true. I'm going to put up your side work. Let's say that this is true. Can you guys simplify the inside of that for me? And of course, if you think about it, what's the only value that I cannot simplify this for? What's the only value that this cannot simplify? 1. And in this whole problem, am I letting the input become 1? No! So I'm totally allowed to go ahead and just simplify this shit without any concern. So what does that simplify to be? No.
X plus 1.
X plus 1. So if you factor the top, x plus 1, x minus 1. The x minus 1's cancel. X plus 1 minus 2. Okay. I got you. You're good. You just got a little ahead of me. And so, of course, this does become. Okay. Now, what did our delta have to do? Didn't our delta have to be greater than this? And if I have an epsilon that's given to me, what does that mean delta has to be? I really want this to make sense. Given an epsilon, what would I set delta to be so that x minus 1 is less than delta? I would set delta to be if delta equaled epsilon. What does this say? If delta equaled epsilon, then x minus 1 would be less than delta. So in this case, it's going to be a perfect square. The little region we're talking about, it's going to be a perfect square because the slope through that point there is going to be 1. I went a little too far, I'm sorry. So in this case, if I make delta exactly equal to epsilon, this will work. All right, so this is all side work. Oh man, I know. I can read somebody's mind right now. They're like, this is just one section. I don't know what the hell this guy's talking about. So in general, we want to find a delta that is somehow related to the epsilon we're given, so that when somebody changes their epsilon, L delta automatically changes. I don't have to do the shit we just did. All right, give me a minute. No. In this case, whatever the person comes up and says, I want you to be within epsilon, we're like, all right, my delta is equal to epsilon. Maybe? This would be like if you took the exact same amount of time to get ready as your friend, and they said, we got to be ready to leave in 20 minutes. I'm going to start getting ready now. You would get ready right then, right? This takes you 20 minutes. So that would be delta equals epsilon idea. Yes?
So is that the answer? Is delta equals epsilon?
No.
The 1-to-1 ratio?
You ready? Yeah, in this case, it's a 1-to-1. Some of you guys are going to see some shortcuts here very quickly. Because fundamentally, what is true about this function? Isn't this function linear? Yes? It's linear everywhere except at 1. And technically, you could say it's sort of linear there because it keeps going just as if It was just going on the same trajectory, right? So you will pick up on some shortcuts. That doesn't mean you can just jump to the answer. Okay. So this is side work. We haven't done the work yet. I like to keep an eye on your eyes until you go like this. Oh, God. Okay. So here's the actual proof. Given epsilon greater than 0, we let delta equal what? We just did a lot of work to figure it out. Epsilon. There you go. That's the whole thing. That's the whole work we just did. Because what does it take to prove this? We need to find delta so that if this is true, then this is true. So that's the actual proof. That's not what this thing did. This whole thing here was just figuring out what the shit delta is. Now we got to go show that it does what it's supposed to do. We let delta equal epsilon. Then, if x minus 1 is less than delta, doesn't that mean that x minus 1 is less than epsilon? Yes? I love you guys. Now, this is where you really just sort of... All right, here we go. Isn't that true? Look what I'm just kind of following this backwards. Right? You guys with me? So this didn't come out of nowhere. I kind of have a blueprint of what to follow now. So isn't this... So it feels a little bit like we're cheating to anybody? A little bit? Maybe? No? You're all like, dude, I'm not there yet, man. I still have no idea what the shit this is. Maybe? So did it do what it was supposed to do? Did we find it so that if x minus 1 is less than delta, then x squared minus 1 over x squared minus 1 minus 2 is less than epsilon? Did we do it? Yes. Done. QED. Or done, or proven, or whatever, or check mark. Oh, I know that was anticlimactic. I know it. I know. Yes?
So what would void homework look like?
Like that.
Just like that?
Just like that. So you got the little side work. So I normally ask you to like put little dotted thing around the side work just to show that that's the side work. And then that's the actual proof, and I want it written up basically just like that. Don't just find delta, circle it, and keep going. No. Maybe? You guys? Yes?
Say that last section one more time.
Oh. Sorry, I was just trying to figure out. You could put a big check mark. You could put QED is a big one, but I forget what the hell that is in Latin.
No, like how
Oh, you mean up here?
yeah, like how that gives you the answer.
Oh. So is everybody cool with this is what we have to show? That is what we have to show. We need to find delta. So if this is true, then this is true. Here's the proof, because what do we do in the proof? We let delta equal that. We found delta, and then we showed that if this is true, then this is true. Didn't we do exactly what we needed to? I like it. So this part needs to be written also, right here. So this is what your homework needs to look like for this section. What would make, yes, go ahead.
Will delta always equal epsilon?
No.
Okay.
We're going to do in a
That's what I
problem
thought.
right now.
Okay.
Right now we're going to do one where delta is not equal to epsilon, just to make sure everybody gets the idea.
And then one more question.
Yes.
Why do we have to prove a limit is a limit at a certain, like, why? Because that was the answer.
Do you think we have done really difficult functions? No. And I love, here's the thing. As you get further in math, and further in math might just mean finishing this class out for some of you guys, right? Some of you guys only need Calc 1. Is that true for anybody? You're going to stop at Calc 1. Anybody going on to Calc 2? Anybody going on to Calc 3? Ah, sweet. The further you get in math, the more theorems we want to build so that I can use them very quickly in problems. I can't build theorems without things like this. This is really easy when the function is nice. And I don't even have to do this shit to really know what the limit is, do I? So that's the part where I need you guys to understand. Listen, this process goes from relatively simple, and I know this is still new, so it's not simple yet, but relatively simple to insanely crazy if I make my function a little bit worse. That's something you don't know yet. I might show you an example of what I'm talking about if we have time. Yes?
Are we ever gonna have to disprove? I mean, not ever. I know we obviously are going to have to, but like on the this homework over here.
I don't think so in this homework you do, but I mean that would be pretty quick.
Yeah.
Yeah. I can't remember off the top of my head. I don't think there is one like that in here. I don't think so. No. Okay. All right. Now let's do one more. What I'm going to call a straightforward example, and then we'll see how much time we have left for a not so straightforward example. Okay. I love you guys. Oh yeah, I do have a handout. I'll give it to you here in a minute. Let's say we have, what do you got, Jeff? F of x equal to, what is it, Jeff? Let's say 3x squared minus, you can do it, buddy. There you go. Look at that. Look at that. You're doing stuff. Okay. We claim that the limit as x approaches -2 for this. Can you do it, Jeff? -12? Is that what that is? Maybe. Yes, okay.
That's just crazy.
I'm sorry, what's...
You can just do all that in your head, like, it's hard for my
Oh.
brain to wrap around that you're.
Somebody else has to be there with me, right?
That's-
Take a 3 out, just let it sit there. You have x squared minus 4. That's easy. X plus 2, x minus 2. The x plus 2 dies. What do you have left? 3 and x minus 2. If x is -2, 3 times -4,
no
and you're
idea.
like, whatever, dude.
Yeah.
So who cares? So you would write it down. You would be given this, by the way,
No, I know.
in this section. In another section, you would just do the steps and factor the top.
Yeah.
Yeah. I kind of feel if I could not do that in my head, I would have to quit. Right? For being a math teacher. As a math student, you don't have to be able to do it. You're okay. So here's the proof. What would I write down? We need to find what? Delta. I like it. Such that, given epsilon greater than 0, if we get within delta of what? X minus, no, x minus -2. Then the function gets within epsilon of what? -12. All right, let me stop for a minute. So for you, it might be a good idea to kind of identify, this is A, this is L. Go back to your notes, plug them in the right places. I like it. So again, the person comes up, gives me a target. That's the epsilon. It gives me a target. So we need to find a delta so that if we're within this much, our outputs are within that target. That is what this says, just a little more formally. Okay, I like it. Yes? You good?
I was thinking about that, but that's one that's yeah, I got it switched up.
It's easy. It's easy to get switched up because all this shit is new. All right. So now we can do it. What's our side work going to look like? Where do we start for our side work? Anybody remember? This is why it feels like cheating, because where do we start for our side work? We start at the end, and we work backwards. So this is a construction proof. There's like a proof class you could take if you want to be a math major. You take a proof class. One of the first proof methods you learn is construction. You construct something that will do what you need it to do. This construction proof is like, the reason this proof is really weird for students is because it does feel like we're cheating. It sort of does, because I'm just doing things backwards and then I'm doing them forwards. But I need to find delta, and that's the only way I can find it, is by working backwards. And then I need to show for real that it does what it's supposed to do. So what part of this would I not put into my math analysis for something I'm submitting to be put in a journal? What part would I not even show? The side work, that's why it's called that. Right? You would just say, let delta be this, and then here's, it does the right thing, right? Okay, maybe. Side work. So I'm going to start with the answer. And then I'm just going to simplify that. Right? Now is where you can do that factoring stuff. I'm going to kind of jump ahead a little bit. Am I going to have any time? Mm-hmm. Okay. I'm going to let you guys keep going. Oh, I've left off this. Sorry. That's key. That's very important. So this is still a relatively simple problem because you end up with a linear function inside, right? So just imagine, does every function have to end up like that? Hell no. But the minute I do something more than linear, the difficulty goes like this. So I will try to show you one example of that. So of course these die. What do I get in here? 3x minus 6 is where you need some faith. 3x plus 6 less than epsilon. Now what's my goal here? Let's see if you guys, what do I want to get to? Don't I want to get to x plus 2 showing up?
Yeah.
So how do I do that? What do I do? Yeah, why am I allowed to do that? Factor of 3 out.
Is they both shared?
Well, they're in absolute values. Because of course 3 is positive, so that won't affect the value. So be really, really careful. You can't factor a negative out of an absolute value, right? Maybe? No?
Yeah.
So I can just go ahead and divide by 3 because it's positive. So what do we want delta to be? What are you? Okay. What do I want delta to be? I want delta to equal epsilon over 3. Do you guys see? I want delta to be epsilon over 3. So no matter what the guy tells me, this is like it takes you 1/3 the time it takes to get than your friend to get ready. So if they give me an epsilon, I cut it in thirds, and I'm guaranteed to be in there. So here's epsilon. I cut that in thirds, and now my outputs will be within there. Forever. That's the key. If my limit was wrong, it would eventually not work anymore. This has to work no matter how big epsilon is or how small it is. All right, so here's the proof. Let me put my little dotted, yay. Right? So given epsilon greater than 0, let delta equal epsilon over 3. I like it. Then, no, let's not put then, Jeff. If x, let me just go ahead and, now I can just copy from myself up here. If x plus 2 is less than delta, that means that x plus 2 is less than epsilon over 3. You guys with me? I know I want to have an epsilon here at the end, so I'm going to multiply by 3. And this is where There's somewhere where it just sort of clicks, and then you go, well, this is stupid. This is too easy. I just do this. I just follow this. Right? So then from here I can go 3x minus 6 plus 12. Then I can go to here. Let's see, how do I want to do this? Yeah, let's do like this. Minus negative 12. Holy shit, I'm running out of room. Okay. Let me come down here. All right, I really want you guys to understand what I'm doing. Aren't I right here? Right? I'm here. Then I just keep going. Boom, boom, boom. And then yes?
Then why is the side work not the answer?
Because it doesn't do what the proof requires. It will, the delta we get from the side work will do what the proof requires, but we still have to show it does what the proof requires. That's the step where I totally get what you're saying. It's like, of course it's going to do what we need it to, because we made it that way, right? But again, you would not show the side work in analysis in a math journal. You would have some funky ass function. You say, well, we're going to let delta equal to square root of epsilon divided by 1.7 pi, right? And then we get blah, 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 barf, and we get the answer. How did we get that weird ass delta? We did the side work on the side. Okay, I totally get what you mean though, but that's the way proofs work, yes.
So we gotta simplify it, and then for the proof we have to
Unsimplify it, yes.
Okay.
Okay, see, I told you, didn't I? At some point, it's going to go, oh, well, that's dumb. All right. And again, it's not dumb. It's why is this kind of too easy? Because, again, the function became linear. The minute the function is not linear in here, you get exceptionally weird shit you got to do. So we're analyzing this proof method at the most basic level, just to get used to epsilon delta. Really, the big thing I want to come out of this is, what does epsilon and delta represent? Because that's what keeps coming back, for sure. Yes?
So if that function is simplified at x plus 2 is less than delta, or epsilon over 3, then delta wouldn't equal epsilon?
No, definitely not.
So if that was like x plus 3, for example, so x plus 2 wouldn't be equal for...
Oh, I see. Yeah, if that was x plus 3, I'd be a little bit screwed.
Okay.
Not necessarily completely screwed, though, but it would definitely not be as easy as this.
That's what makes it equal, though, that it simplifies to the same thing as...
Yeah, because this is exactly the form that this is supposed to be in, so I can identify delta quickly. Will it always be a one-to-one correspondence? No, especially if my function is worse than linear. Then I've got to do some other weird shit. All right, and then and of course we already know, I can take that last step, go all the way back up to the top, and I've got exactly what I needed to show. So somebody gives me an epsilon. I have found a delta, so that if this is true, then my outputs do what they're supposed to do. No matter what epsilon is, correct? What could epsilon be? It could be 1 times 10 to the negative 99, right? Negative, it could be 1 over a billion to the billionth, 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 to the billions, to the billionth. And now we'll divide that by 3 and everything would be great. So do you guys get a feel for the technical explanation of what close is? Close means epsilon greater than 0. Maybe. And of course, this side is delta greater than 0. So I think what I want to do, this class goes to 10:20, right? Yeah, okay. Let's see if we can do this. Oh, let me give you this. Before I do a freaky ass problem, let me give you this here. Here, let me do. I'm not going to do a freaky ass problem today. I think I'll do it next time. 2-4. Oh, I got it up on this thing too. I'm sorry. It's no problem. Your math teacher just can't count. Is that All right, so I think, let's see, in the little bit of time we have left. So I try to capture some kind of visual for you to have with you. Of course, the book's got some other stuff too. I gave you a fully fleshed out problem. And then I want you to try to do this one. So let's do that in the time we have left. You guys try to do this one.